All right, let's start with an attendance ping so I don't forget.
Yeah, I gotta say, I think PA4 has probably been the funnest programming assignment I've done.
Oh, awesome. That's great to know.
Just because the bash stuff is so different than other languages.
Mm-hmm. I knew how to write scripts in Bash long before I actually started doing it on a regular basis. Because I was kind of like, write code in C, that's how you write programs. But I think it was once we locked down back in April, however many years ago that was, and I was teaching summer online, and then when it became clear that fall was going to be remote also, I started wanting a bunch of tools to do things like set up my document camera and my wall camera automatically, and set the resolution and put them in the right place and all. And so I started wanting a bunch of tools to help me do this, and I just began writing a bunch of Bash scripts, and I really kind of fell in love with Bash. It's possible to do so many things that would take a lot longer in something like C or Java. And it's a pretty quick development, and a few tools like dialog, let you pop things up and so on. You can really have a lot of fun with it. So
Yeah, I've been noticing because I've used the man pages before, but I've never used them this much.
mm-hmm.
And I've been noticing that, like, no matter what you want to do, you just got to think about it. Like, oh, this is what I want to do. You go on the man pages, and it tells you what options you can use to do what you want to do.
Yeah, totally.
Like, even as much as, like, on the dialog, taking the cancel button out.
Mm-hmm.
You know what I mean? Which I did find out, you still have to account for the escape button.
Oh, yes.
I pretty much put the finishing touches on my cases yesterday for escape and enter and cancel.
Okay, cool.
Actually, I did have a quick question though.
Go for it.
On the project, so when you pop up an input box, if the user just hits enter, what is that? I tried looking it up. I tried doing a new line. I tried doing like a line terminating, but it just always freezes my program. Everything else runs great.
Well, let's see. So let's do an input box. And we'll do our output -fd1 like this. All right, so if we say hello, then x is just equal to hello. So if the person just hits, OK, x should just be an empty string. And so you should be able to do something like an if statement to see if it's equal to just quote.
See, I tried that in my program, but for some reason it doesn't do it. It just exits, or it sits there in like an infinite loop. And I've looked at it several times, like tried doing it like this. I even wrote a test program and was able to get some of it to work, but still, when I hit enter, it just freezes, even the test program.
Interesting.
So
yeah, I don't know what that would be. Try doing some echoes after you get your variable, and see if that helps. You can also write outputs into a file. Right, so if I do this, I can go into debug.txt and see what things look like, or I can xxd it and see that there's just a single new line inside there.
Yeah, see, I even tried doing 0A. I did some research and people were saying that's just the enter key, like what bash sees the enter as.
Yeah, but so when you do the enter, it should come out with a length of 0. And there's some other things you can do to check for a length 0 string. Like I think you can do a if-z and then put in the name of the variable. But this should definitely get you there. And if this does not work, go ahead and echo $x, but echo it inside, some sort of delimiter like that. And if it's equal to a space or something, right, you'll see a space between these, and that'll be a giveaway. And it could be something peculiar on your operating system or your setup compared to what's happening here. But if this does not register as a true condition, you should be able to echo $x, and it should be something other than just this.
Okay. I'll try that.
Okay.
Thank you.
Yeah, you're welcome. Yeah, dialog is very sensitive. That's definitely true. The manual page for it kind of gives you a hint of how many options there are involved. And particularly with things like, radio lists or checklists, the options get complex pretty quickly. And it's not always very good at telling you what's going wrong. And the other thing is, because you're popping up this dialog which fills your whole window with, a blue background or something, if you get error messages from your script, sometimes you won't see those. Right? So there's been a number of cases where people were trying to do something like this. And doing this instead. Well, this will generate a syntax error, right? Because bash doesn't understand x space equals, right? But I don't see that syntax error because it got obscured by, all the stuff that showed up on my screen. And so if I'm doing this inside a script, right, my errors might not be visible. And that can be tricky to deal with, but yeah, I don't know what a good way is to deal with that, other than to look at your code really carefully. Something you can play with. Sometimes scrolling up will show it to you, yeah. Something you can play with, and this, your mileage may vary, but in the beginning, where you put your shebang, if you put in a space dash lowercase v, that'll add a verbose switch to your bash. And so, for example, let's forget about dialog for a moment, but let's just say I equals 0. Alright, so here's a sample bash script. It just increments a variable and loops from 0 through 5. If I put a dash v in the beginning here, I get some additional information. Right, when I say try, it shows me the lines of my file as they're executing. Right, I equals 0. And it's not really giving me that much information. Yeah, that's probably not terribly useful. It may help with flow control, with knowing kind of where you are in your script. -X gives you more information. So here it's showing me the values of variables. It's showing me conditions. J equals 0. Here's where my I got incremented, and now it's comparing 1 to 5, and it's echoing I equals 1, which it did there. And so there's switches you can put on Bash, and -X and -V maybe too that help you. And that might be useful with these longer scripts, especially where you have, you know, this dialog command that has its own challenges. All right, well let's hop into the ODPs. Oh, so reminder, no class tomorrow, right? So Thursday is Veterans Day, so holiday across campus, no classes. So no classes here, no office hours for me in the morning. But we'll be back Friday, and I'll have office hours Friday as well. So let's look at ODP 416.
So with that being said, I didn't see there's an ODP Friday.
Mm-hmm.
Is that, are we going to talk about that one today?
Yeah, we'll talk about that one today also.
Oh, okay.
Let's see, it caused me a lot of pain trying to put commands into variables. Burning Bash, you have to use an array instead of a text variable. You can use the backquote trick. You don't need to get into arrays.
I pretty much backquoted everything. That worked pretty well.
Okay. I'm kind of curious here. Hold on one sec. Yeah, so this business of putting quotation marks inside commands, you can backslash quotes, and sometimes get things to happen like that. So I could say, you know, X equals quote hello, and then if I echo $X, I just see hello, I don't see the quotation marks, right? But if I say X equals backquote hello, and I echo $X, now I've got my quotation marks as part of my variable. So this backslash in front of the quotation mark says, hey, I'm not saying, you know, that I want this quotation mark to end what I started with this quotation mark. The backslash says this is just another character. This is just, you know, ASCII code 34 or whatever it is. This is just a quotation mark. And so X is equal to a quotation mark, HELLO, and another quotation mark, and I've put all of that inside quotes. So that'll get you there sometimes. All right, so all right, so let's look at 416. So let me hop onto the server. So I mentioned in the other class, it's worth mentioning here, I moved my desk around yesterday. I switched like sides of the office with my fiance, and my whole setup is backwards now. And you know, when I want to move from one desktop to the other, I have to scroll in the opposite direction. And if I switch that, then all of my tags are on the wrong window. So if I'm moving things around in weird ways today, that's part of it. And yeah, I definitely believe you. When you get into more complex strings, it's not as easy as doing an escape on the quotes. And there was one case a long time ago where we were trying to do something like this, and we ended up having to use like 4 pairs of backslashes to make this thing work. and none of us knew why it worked. But we tried, doing an escape, and we tried putting in a second escape to escape the backslash, and the third, and just out of desperation we tried a fourth, and suddenly it started working. It's a weird area, and it's one of these areas where, there's other languages that will let you do things like this in a very reasonable way. Bash lets you do things like this, but it's not necessarily a very reasonable way to do it. And you can get around this somewhat by doing things like, creating a script and executing it. You can create a script on the fly and put statements into there and then run that script from your main script. And sometimes that's an easier workaround also, or using arrays. Alright, so ODP 416 was the remove command that takes a string and removes all occurrences of an X. And this, I mentioned, is a general kind of algorithm where we basically have two strings. We're using the input string to somehow create the output string. And the trick to making this work is to have a pair of pointers, a pair of indices. One which moves through the input string and a separate one which moves through the output string. And it's important that we have a pair of these indices because, for example, suppose you want to write string copy. And so in is, hello, and you want to create an output string which will look like hello. Well, this is pretty simple. We just copy from index 0 to index 0, index 1 to index 1, and so on, index 4 to index 4, and we could even copy the null terminator by copying from index 5 to index 5. So in this case, where we're just trying to make a copy of a string, we could have a single variable I that we use to march through our input string, and our statement is simply output I equals input I. And in the case where we were interleaving two strings, Monday's ODP, right, we were able to do some index arithmetic that looked something like this. Where we knew what the output index should be based on the input index. So we could still get away with one index. But for things like removing x's, right, we don't know what the output position is corresponding to each input position. And so here it's useful to have a pair of indices. One that moves through the input and another that moves through the output. And those are going to be out of sync with each other. If our string starts with a bunch of x's, our input index is going to start skipping over those. Our output index will still be at 0. Because when we get to that first non-x character, we want to copy that to output position 0. And then the next character that we want to copy is going to go in output position 1. So we use a pair of pointers. And so we can look at code to do this. Right, so here's my output location, which I initialized to 0. Here's my input location, which is traversing the entire string. So it goes from 0 up to and including string length, because I wanted to copy the null terminator, and that's not an x, so it'll get copied. And then basically, if the input string at this input location is not an x, copy that input character to the output string, copy it at the output location, and then after we've done the copy, increment the output location. And so remember, this is a post increment. This says use output location as the index, and after you've used it, increment it. If we said ++oloc, that would say first increment oloc, and then use that as an index. So if I initialize this to -1, that might be appropriate to do a ++oloc. Alright, so someone just posted a specific example. I'll try that offline and see if there's an easy workaround for that. But yeah, I think you're right. It's probably increasingly complex. All right, so let's think about ODP 417. So 417 is just like 416, except it's the remove one function. So remove removes all occurrences of x. Remove one removes just the first occurrence of x. So if your string has an x in it, the first x that the function encounters does not get copied, but every other character gets copied from the input to the output. So if your string is something like, you know, Haxon, the output should be HAON. If it's HAXXXON, the output should be HAXXON. This first X got dropped. If it's HAXONOXXO, this would be HA, the first X gets dropped, ONOXXO. So it copies the input string to the output string, but it drops the first occurrence of the letter X. And if there is no letter X, right, then it just copies the input to the output. And if the input string is empty, the output string is empty. And if the input string was just an X, the output would be empty. And if it was, you know, 3 X's, the output would be 2 X's because the first one got dropped and the others got copied. And these are all, you know, good test cases you should be doing in your own test program before you try to assess. So the reason for this ODP is that it's an example of what we can call stateful programming. So let's just sketch out some pseudocode for 416 and then think about how we modify this for 417. So here's a for loop, and we're going to loop over. I'm going to go up to and including string length, so we'll do the null terminator. That's just, you know, something to do at the end. But for each character in my input string, if that character is not equal to an X, I want to copy it to my output string and increment my output loop. So that's ODP 416. Okay. For 417, what we want to do is exactly the same thing, except that after we've seen one X, we want to skip this condition. We just want to copy every character from the input to the output. And so we can think of this in Engineering 250 terms as a notion of state. This program, this function, can be in one of two states. In its initial state, if we find a letter X, we're going to ignore it. Otherwise, we're going to copy our input to the output. But after we found an X once, it's going to go into a second state. And in that second state, each character in our input is going to get copied to our output, regardless of whether or not it's an X. So this is like a state machine. And it's got two states, and it's the same set of code. We can't change the code at runtime, right? It's the same function, but it does different things depending on what's happened in the past. And anytime you have a situation like that, you can think of it as a state machine. So a state machine in Engineering 250 is a piece of circuitry. It's sitting on your proto board. You don't change the wiring to get it to do different things, right? But it does different things based on what's happened in the past. And so this is a software version of a state machine. And we want to note using a state variable, a flip-flop if you will, but we're just going to use an integer. We want to note whether or not we've seen an X and removed it from our output string. So this boils down to the following, right? The first time I find an X, I'm going to use this if statement to make sure I don't copy it to the output. But once I've seen an X, I want to set a flag, a variable, to say, hey, I've seen an X, I've removed it from the output. From this point forward, I want to copy everything. So I'm just going to make another integer. I'm going to say it, I'm going to call it saw and X. I'm going to set it equal to 0. And I'm going to say set this to 1 after you've seen an X. So this is my flag, this is my flip-flop. When it's 0, I'm in the state where if I see an X, I don't want to copy it. But after I've seen an X, I'm going to set this variable to a 1 to tell my code, hey, you've seen an X already. And at that point, I'm going to copy all my characters. So let's adjust the state variable. If input bracket in location is equal to an X, then saw and X gets set equal to 1. And up here, I'm going to add something to my if statement. If my character is not an X, or if I saw an X. If either of these is true, then I want to copy my input to my output. And that'll turn ODP 416 into 417. All right, so let's flow through this. If we're a computer, saw an X is initialized to 0. So the first time through, if I don't have an X, I'm going to copy. That's fine. The first time I encounter an X, inloc is not equal to X. Well, that's going to be false. Saw an X is equal to 1. That's going to be false, right? Because my flag is initialized to 0. So this if condition will fail, and I will not copy that X. But since that input character is an X, I'm going to change this flag to be a 1. From that point forward, if I encounter a character that's not an X, this condition will be true, I'll copy. If I do encounter an X, this condition will fail, but this condition will be true. This OR will be true, I'll copy. So every time from this point on, I'm going to go ahead and copy my input character to my output. All right, so that's like stateful programming. That's paying attention to the current situation and using that to remember something so that in the future we do something different. All right, if you do less than or equal to string length, you still got to deal with the null terminator, which at the end of the whole loop would still just be out bracket outloc equals \0. All right, so questions about that? All right, so let's look at ODP 418. So 418 is the same idea, an input string being used to construct an output string. But this time what we're doing, instead of removing a character, is we're moving a character from the beginning of the string to the end. So if your input string is HELLO, your output should be ELLOH. So this first character gets popped over to the end, everything else gets moved down one spot. And we can approach this the same way as these other ODPs, which is, let's just think about copying from the input to the output. So if your input string is A, B, C, D, E, we want our output to be B, C, D, E, A. So this is an oddball. This A gets copied over to the end. That's kind of strange. But other than that, the behavior is each character gets copied one position prior to its location in the input. So in general, we're going to do out I minus 1 equals in I. So out 0 is going to come from in 1. Out 1 is going to come from in 2. Out 2 comes from in 3. Out 3 comes from in 4. And then out 4 in this case would come from in 0. That's the oddball case. Alright, so how do we put this in a loop? We can't start I at 0, right? This formula does not describe where the letter A should get moved. This would say move the letter A to index minus 1. That's a segfault invitation. But as long as our index is 1 or greater, this formula describes what we should do. So I'm going to say for I equals 1 to string length of the input minus 1. So this will work for indices 1, 2, 3, and 4. And remember, string length is going to return a 5 here. So index 1 will get copied to 0, 2 to 1, 3 to 2, and 4 to 3. So that gets most of your characters copied. We still need to copy character 0, and that's going to go in this case to output index 4. Well, it's 4 because it's the last output position we want, and we know what the last output position is. It's going to be the string length of our input minus 1. So we could say out bracket string length in minus 1 equals in bracket 0. Right, so this is 5, 5 minus 1, that's the index of the last character in our output. That's where we copy the first character. And then you got to do the null terminator as usual. And if our string length is 5, then that's the index where the null terminator goes. So out bracket string length in can be set to the null terminator. And this works great except for edge cases. So I've mentioned edge cases a few times. Someone mentioned in the last section. I've never really talked about what an edge case is. So an edge case is something that breaks a pattern, basically. For example, you know, this will work if I have an input string like A, B, C, D, E. This will work perfectly. It'll copy B, C, D, and E here. It'll copy the A over to here, and it'll put an null terminator on the end. But this will not work if my input string is blank, for example. Well, it might actually. Yeah, it will not. Because if my input string is blank, string length of in is 0, this is going to try to set my output string at index minus 1 equal to a null terminator. And I don't want to access, you know, element minus 1 of an array that's possibly going to segfault. So this would be an example of an edge case. It's something that breaks this algorithm. Because this algorithm is making certain assumptions. It's assuming that we always have a minimum number of characters in our input. And so
conditional to fix that, right?
So you can write a conditional to fix that, but you got to write that conditional. And if you don't, then, you know, when you try to assess some of the tests you get points, some of the tests you don't. And so when you're writing your algorithm and you're testing it yourself, you want to test not just A, B, C, D, E, but you want to test an empty string. You want to test a string with one character, test a string with two characters, and then, test a string with more characters. Empty strings are usually an edge case. In this case, since we're doing something different with the first character and copying it to the last, it feels like this might be an edge case. So it's worth checking that. This one probably works the same as this one, but double check those. And so for, this remove 1x, right, what are some possible edge cases? Well, a case where you have no x's at all could be an edge case. An empty string is an edge case. A case where you have a single x in your string and nothing else, because your output string is going to have to be empty. That's an edge case. A case where you only have x's could be an edge case. Case where you have a single x in the middle of stuff. Case where you have multiple x's next to each other. And case where you have x's that are separated by other stuff. Those are all possible test cases. And they all test possible assumptions that you've made in coming up with your algorithm. And so once your algorithm is working correctly, there are no edge cases, right? Every possible set of inputs has been accounted for. And that's kind of what the ODPs are testing, right? When I write the test cases for the assess function, I'm trying to think of different ways you might write your algorithm and different assumptions that might be in there, and I'm making sure there's test cases that exercise those conditions. And as I've mentioned, right, being able to test your code after you've written it is a huge part of being a successful programmer. Because that helps you know that your code that you're delivering is going to work correctly, but it also improves your ability as you're coming up with an algorithm to be thinking about, what might be different, what might I be assuming here that I shouldn't assume, right? We often assume that a string is not, empty, and so we're fine with doing something like, moving down its length and assuming we're going to execute our loop at least once. All right, so that's some comments on ODP 418. So 418 opens tomorrow morning at 10:05 and it's due Friday morning at 10. And I'll still have office hours Friday morning. All right, so questions about any of that, or about PA4, or about any of the other stuff? Okay. Reminder, PA4 is due on Monday, and we're going to begin presentations in class on Monday, where you'll demo your program's features to the class. Today was the deadline for letting me know if you're working in a group, and I think I've only heard from like 3 groups so far. So either everybody's working alone, or people have forgotten to let me know what their groups are. So if you're working in a group and you haven't told me yet, tell me today. Tell me like right after class, according to the instructions that I gave. So send me an email, subject line as indicated, and body containing the full canvas names of all the people in your group. I only need that from one person in the group. I don't mind if multiple people send it to me, but I only need it from one, and I'll put everybody in the group, and I'll send you a note, let you know what your group number is. And then I'll come up with an order of presentations later this week, and Monday morning we'll just go through the groups in whatever order randomly was generated, and you can tell the class what you did and show us your code, show us your special features, and so on and so forth.
I got a quick question.
Yeah.
Reading through the instructions, some of it is a little vague. As far as the delete function, you said someone should easily be able to go in there and delete something.
Mm-hmm.
So the way kind of mine works is it pops up all your upcoming appointments, and then it pops on the next screen an input box says which one you want to delete. And
Okay.
It uses a grep function for that.
Cool.
So you can put either the description or the date, but it doesn't have that input box and the appointments on the same screen at the same time.
That's okay.
It's okay. It's still pretty easy to do, but just wanted to make sure that wasn't like, no, it has to be a.
Yeah. No, I think that's good.
Okay.
Yeah, long as there's some way that somebody using this could say, oh, I don't want to have lunch with so and so anymore on Friday, so they can go in and remove that. But don't just pop up like a file editor window and say go ahead and delete this line from the file by hitting a bunch of backspaces over it or something like that, because then they can go in and they can do all kinds of things.
So I did do that for the edit function though. I implemented an edit function. And what it does is it takes the one, so it asks which appointment you want to edit, and then it takes the one appointment, puts it into a temporary file, and then it does an edit box on the temporary file. So there's only one thing in there to edit.
Cool. That sounds great.
That's okay?
Yeah,
cool.
I like that.
Yeah, once we started using the grep, I found that it was pretty useful the code for delete and edit are pretty similar, which is kind of cool.
Yeah, definitely. All right, so so there's instructions in the assignment on how to let me know about your group. So email, there's the email address, there's the subject line, and then body just contains canvas names of people in your group. So go ahead and do that. Oh, you got till noon, so you've got 16 minutes left to send me an email. Cool. And yeah, if you're still looking for a group, Discord's a good place to ask about that. So somebody posted an example of trying to use a variable with grep. Posted this in chat about 11:09. So grep does not necessarily need quotation marks. If you have a pattern you're searching for that includes spaces, right, you can put your pattern inside quotes, and those spaces will be honored. You can also escape those spaces with a backslash in some cases, and do your searches like that. You can also take the output of grep and pipe it into another grep. So if you want to look for multiple things on a line, you could, grep for pattern 1, pipe the result into grep pattern 2, pipe the result into grep pattern 3, and that would give you lines that contain all of pattern 1, pattern 2, and pattern 3 on the single line. And so that's a possibility. All right, so other thing I'll mention, so Friday we'll talk about a few more things that might be helpful, but we talked a little about awk, and don't underestimate the value of using awk to help process your appointment file. So So let's say I read a line out of my file and stored it in a variable D, and D looks like this. It's got a date, it's got a name, and it's got a description of an appointment, right? So an easy way to break this up is to use awk, and I can say let's use awk with a field separator of a pipe, and let's say print, let's say I just want to know what the appointment was. I can print $3. And this will read from standard in, look for things separated by pipes, print out the third such field on each line. So if I echo $D and I pipe that into awk, and then print $3. Oh, you got to escape the pipe though, right? That'll show me the third field of this variable. So when you're creating your calendar file, right, you can just echo with, say, pipes in between, you know, the date and the name or whatever your fields are, and you can create a line of text that's, you know, pipe separated. That's pretty straightforward. To split it up back into individual fields, awk is a useful tool. And so specify the field separator, and then quote curly bracket, you can say print $3 to get the third field, and you could print $2 to get the second field. I could print $2 followed by a space followed by $3 to get the second and third fields with a space in between, and so on. So awk is useful like that. So if your partners want to be able to write to your /temp file, unfortunately, the granularity we have, really your only choice is to make that file mode 777, which means everybody can write to it. But we're all playing nicely here, right? Because we don't want to wreck other people's calendar books. So yeah, you can just make it universally writable like that, and hopefully nobody steps on it. If we were doing this in a more sophisticated setting, you could create a group that contained your users, and then you could give the group write access to the file, but not the rest of the world, and then, you know, precisely those people. And my suggestion was, you know, under /temp, under /temp /calendars, put in your group name, right? Don't just make a file called, you know, calendar.data or something like that, but make a subdirectory for your group name. So as you form a group, I'm giving you a group number, so you could be, you know, group 2, or you could use, you know, your own name. So, you know, I could do Nick M or something like that, and then put your files under that directory. And then anybody else, say again?
Is there a benefit to putting the temp files there instead of just storing them on the local machine?
Only if you want to share with other people. Like if you're working in a group and you want other people to be able to access the file, then you don't have to give them write access to your directory and such.
Okay, that makes sense.
And if somebody else, you know, thinks that their name is group 2 and they try to create this directory, they're going to see the directory already exists, and that'll compel them to choose a different name. You can use GitLab for sharing code, but not for easily sharing the calendar file. You might be able to rig it together somehow, but that's going to be pretty kind of intense. But you could do that, assuming that everybody is going to have access to that GitLab repo when they run your calendar program. But it's probably preferable to just have it use a file on the current system. All right, we are out of time, so go ahead and send me an attendance note on the way out, and I will see you all next time. Have a good Veterans Day tomorrow.
Have a good one.
Thanks.